Hello. So today we are going to be doing the 2003 AP Calculus AB FRQ number 2 from Form B. So the FRQ says for 0 is less than or equal to t, which is less than or equal to 31. The rate of change of the number of mosquitoes on a tropical island at a time t days is modeled by r of t is equal to 5 times the square root of t times the cosine of t divided by 5 mosquitoes per day. There are 1,000 mosquitoes on tropical island at a time t equals 0. So A, show that the number of mosquitoes is increasing at time t equals 6. So here I wrote out r of t already. So for part A, all we're going to do is go ahead and plug in 6 for t. And my suggestion for this would be to go into your calculator and press y equals, and then type in 5 square root of x times the cosine of x divided by 5, just to make it a little bit easier. So anyways, what we are going to do now is so we plug in this r of 6 into that, and once we have that in our calculator, it becomes a lot easier. We end up getting 4.438. So this number is greater than 0. And what we're going to be able to say is that, box right there, part A, because r of 6 is greater than 0, r of t is increasing at time t equals 6. There we go. All right, that's part A right there. Oh, that's not what I wanted. All right, part B. So part B says at time t equals 6, is the number of mosquitoes increasing at an increasing rate, or is the number of mosquitoes increasing at a decreasing rate? Give a reason for your answer. So for part B, what we're going to want to do is to find if a function is increasing or decreasing, we test the derivative in the derivative. So we just test the first derivative of r of t evaluated at t equals 6. Once again, using our calculator, this becomes very easy, and we end up getting negative 1.913. So this number is less than 0. So we are able to say that because the rate of change of the number of mosquitoes is negative, the number of mosquitoes is increasing. The number of mosquitoes is increasing at a decreasing rate. There we go. All right, part C. Part C is asking us, according to the model, how many mosquitoes will be on the island at the time t equals 31? Round your answer to the nearest whole number. So for part C, we're going to let a of t represent the amount of mosquitoes. I'm going to put it right there. Number of mouse. So then we could say that a of t is going to be the integral of our rate function, r of t dt, plus our initial condition, which is 1,000, that's given to us in the beginning. Right there. Alright, so now we're just going to try to find a of 31. So we plug in the integral from 0 to 31 of r of t dt plus 1,000. When we plug that into our calculator, we end up getting 964.335, sorry. So now we go ahead and we're going to want to write out for part C. To the nearest whole number, there are 964 mosquitoes on tropical island at t equals 31. All right, part D. Part D is a fun one. All right, part D says, to the nearest whole number, what is the maximum number of mosquitoes for 0 is less than or equal to t, which is less than or equal to 31? Show the analysis that leads to your conclusion. So the first thing is that we want to find a max. So we want to find our critical points. So if a of t is equal to this, and we take the first derivative of that, then we end up just getting a prime of t equals r of t. So to find our critical points, all we have to do is set r of t equal to 0. So 5 square root of t times the cos of t over 5 equals 0. So now we're going to use our zero product property that lets us just say that 5 times the square root of t equals 0. And the inverse cosine, the cosine of t over 5 equals 0. I was skipping a step ahead. So this one's pretty easy to evaluate. We divide both sides by 5 and square both sides, we get t equals 0. Pretty easy there. This one requires an additional step, a few additional steps actually. We're going to take the inverse cosine of 0. That's going to be equal to t over 5. The inverse cosine of 0 is, that happens at pi over 2 and 3 pi over 2, which are both equal to t divided by 5. When we multiply both sides by 5, we end up getting 5 pi over 2 and 15 pi over 2 equals t. So now what I like to do is I like to take these values and set them up on a number line. Let's get a decent... Oh, that was just bad. All right. That was a little better. So we're going to say, let's do them in blue so they kind of pop a little bit. So 0, and then we have 5 pi over 2, which is just 2.5 pi. A little bit easier to write that out. Then we have 15 pi over 2, which is just 7.5 pi. I just totally covered up the dot. And then since we're looking for absolute maxes and mins, or just absolute max, I guess, we have to test our endpoint as well. It just so happens that t equals 0 was both an endpoint and a critical point. So 31 is being tested as well. So now what we're going to do is we're just going to plug in numbers in between our critical points to find if r of t is positive or negative on those intervals. So from 0 to 2.5 pi, when you plug it in, you end up getting that this is positive. From 2.5 pi to 7.5 pi, when you plug this in, you end up finding that this is negative. And from 7.5 to 31, you end up finding that this is positive. So now let's remember, a maximum occurs when we have something that looks like this. If this is an xy plane, that's x, that's y. A maximum basically occurs when the slope goes from increasing or positive, I guess, to 0 to negative. So when we have something that goes from positive to negative, that means that we have a maximum. When we have something going from negative to positive, something like that, that means that we have a minimum. So let's just get that out of there. All right, so now I kind of like to draw out the slope. So we say it starts here, it goes like that, and then it hits 0 right there, comes down, the slope goes down, the slope's going down until 7.5, and now it's going up again until 31. So this is like something of kind of what the function would look like. Obviously it's not exact, we don't know the exact y values or anything like that. But this does give us a good idea of what our possible points can be. Obviously 0 is not a point that's possible because they get bigger after 0. And also 7.5 pi is not possible either because, like I just showed, it's a minimum. So that means that we have either 2.5 pi or 31. So now what we're going to do is we need to find how many mosquitoes. To test absolute maxes and mins, we test those in the first derivative. So we're going to test this in our A of t formula. So we're going to say like A of 2.5 pi, I'm going to switch back to black. A of 2.5 pi is equal to the integral from 0 to 2.5 pi of r of t dt. That's a pi, all right. Plus 1,000. So if we use our calculators again, we end up finding that this number is 1,039.357. So now we have to see, well, how many mosquitoes are at 31? We already know that answer. That was found in part C. There's 964. So this just tells us that we have the most amount of mosquitoes at the time t equals 2.5 pi. So D, the most amount of mosquitoes on tropical island to the nearest whole number is 1,039. The maximum occurs at either 2.5 pi or 31. I'm going to change that to where it says t equals, or t equals 31. At t equals 31, there are 964 mosquitoes. And at t equals 2.5 pi, there should be equals. There are 1,039 mosquitoes. Therefore, the most amount of mosquitoes on tropical island is 1,039. That's your answer. All right. Thank you guys so much for watching. Thank you. I hope you enjoyed learning with me. I enjoyed learning with you.